All right, so now I'm going to give you the second part of the note for laws of exponents and exponential functions. I'm going to give you the second part. I gave you the first part of it. We did on page 21. And so now we did axis of symmetry on page 22. And so now this is going to be page 23. Okay. All right, so this is page 23, and we're going to do more. We're going to do exponential functions. All right, so let me make sure I got this in. Okay, so now look at this. An exponential function is a geometric sequence, okay? That's number one. It's a geometric sequence. Then what is a geometric sequence? A geometric sequence is where you multiply to get to the next number. Okay, it's where you multiply to get to next number. In the function, okay? That's what a geometric sequence is. So not only is an exponential function a geometric sequence, but it increases or decreases by a percent. Okay, and also it increases or decreases by a percent or common ratio. Okay. Where it increases and decreases by a percent or a common ratio. Okay, so what does an exponential function look like? Okay, they look like curved lines. They are curved lines. Okay, either the curved line is going up or the curved line is going down. It's not a U shape, but it's a curved line. Either it's going up or it's going down. If it's going up, this is exponential growth. Okay, and if it's the curve is going down, this is exponential decay. Okay, this is exponential decay. All right, so the standard form for exponential functions, let's do standard form for exponential functions. Exponential functions, that means what most exponential functions look like is y is equal to a times b to the x power. Okay, where of course you know we have different names for x and y. They're the same. We say x is input, y is output or total. Oops, sorry. X is domain. Your y is your range. Your x is your independent variable. Independent variable. Your y is your dependent. It's the variable that depends on whatever x is. X most of the time is dependent, is independent. It's time, minutes, years, months, days. It's independent. It can stand alone. It's unaffected by the y. But the y is definitely, or the total for y, whatever the value of y is affected by whatever x is. So y is always going to be your dependent. Most cases, it's going to be your dependent. It's going to be a dependent variable. Another way to write y, and we cannot forget this, is f of x. Okay? Another way to write y is f of x. And sometimes you'll see instead of y, they'll put f of x in its place. Don't get confused about that. It's still an equation. All right, so now you have your A. This number right here, A, is your starting amount. This is your starting amount or your y-intercept. Y-intercept. Okay. Okay. This is your common ratio. And sometimes, not always, starting. We'll just put starting now. Your B is your common ratio. That's the number that's being multiplied to get to the next number. Okay. That's the number that's being multiplied to get to the next number in the function. All right. Okay, so let's do an example, or let's also talk about let's break down exponential growth and exponential decay just a little bit more. Okay, we're going to do that just a little bit more, but before I do that, I'm going to do a generic example. I am going to go ahead with a generic example here. So, example. Let's suppose we have a list of numbers, and it's a geometric sequence, so that means it's an exponential function. So we may have 7 as your first number, 21, 63, 189, 567, and 1,701. Okay, so let's suppose these are our numbers that are in the list. This is the first number in the list. This is the second number, third number, fourth number, fifth number, sixth number. So you can always write this as a sideways table where this is your number term in the list. That's your x values, and these are your y values or your output. Okay, so you can almost just do like a little function table. Okay, so now if I'm writing this as an equation in this form, where your standard form for exponential functions, I need to figure out what the starting amount is, and I need to figure out what the common ratio is. I don't know what the starting amount is because it gives me the first number, not the zero number. Your starting amount is your zero number, not the first number, but the initial amount where x is equal to 0. You got to remember that. Your starting amount is always going to be where x is equal to 0. And here x is equal to 1. So that's the first number, but that's not the initial or the starting amount. It's just the first number, okay? All right. So you're going to do your common ratio first, your B first. So what are you multiplying to get to the next number? Okay. Here from 7 to 21, you're multiplying by 3. You're multiplying by 3 here to get this. So your common ratio, as you notice, you're multiplying by 3 to get to the next number. Another way to do that, you could work backwards. If you can't recognize that, then start backwards. Start with this number and work back this way. You say 21, instead of multiplying, since you're working backwards, do divided by the number in front of it. And that's how you get 3. You do another, do 63, work backwards. That means go this way. You can do 63 divided by this 21. Go back this way, and you see it's 3, and so on and so forth, okay? So work backwards. If you don't know what the common ratio is, what's being multiplied to get to the next number, work backwards by using division. All right, so my common ratio here is 3. So that means I know what the previous number before. I do the same thing again. I divide by 3. Multiplying by 3 goes this way. The opposite of multiplying is dividing by 3 to go backwards. So we have 7 divided by 3. And so that gives us 2.3 repeating, or we can say 7. We can say 7 over 3. Okay, either way. Okay, doesn't matter how you want to write that. So then the equation is going to be y is equal to your a, which is the 7 over 3, or you can write it as a decimal, times 3 to the x power. This is how you write that exponential function. Now, if I'm writing A recursive, and by the way, since you can substitute any x value to figure out what the y value is, this is an explicit equation or formula. It's an explicit formula or an explicit equation because you can substitute any number for x to figure out what the y is directly, okay? So recursive, and if you forgot all about recursive and explicit, please go back and read your notes on recursive and explicit. For recursive are going to be equations or formulas where you have to use the previous number to get the next number. So the recursive formula that I'm going to use is called next now. Okay, that's a popular one that they love to use. So my next now formula for this, you always generically have to say what you're starting with. And it doesn't matter if it's your zero number or not. The first number that they gave you is going to be what you're starting at is going to be for this next now. And unlike what we had to do here and work backwards, we could use that number, but most of the time it's the first number that you see that you're going to use as you're starting at for recursive. So we're starting at number 7, and we're going to say our next number is always going to equal to whatever the current number is, whatever that current number is, that's our now, and you're multiplying by 3 to get to the next number. So I'm going to use a dot times 3. And so this is my recursive formula because I have to use the previous number to get the next number. And if I'm looking for the 10th term, I got to use this formula 10 times. Unlike here, if I'm looking for the 10th number, all I have to do is plug in the number 10 to get my answer here. So that's the difference between explicit and recursive. This I would have to actually do 10 times, and this I could just substitute 10 into the formula and get my answer. That's the difference between recursive and explicit. All right, so now let's be more precise about exponential growth and exponential decay. Let's start with exponential growth. Okay, so exponential growth. How do I know by looking at an equation that is exponential growth? A graph, of course, you can tell because the line is curved going up. But for an equation, y is equal to a times b to the x power, you have to look at your b, okay, to know. If your b is greater than 1, then it's exponential growth. That's how you know. B has to be greater than 1 and for it to be an exponential growth. All right, so this is the generic formula for all of your exponential functions, whether it's exponential growth or exponential decay. There is, however, a formula for exponential growth. So we have exponential growth formula. There is a formula for exponential growth, and that is y is equal to, this is the same. Instead of using A, we're going to use the letter C, which is the same as A. It's still our starting amount, times, okay, or let's do parentheses, 1 plus R. Now, 1 plus R is equal to B, and B is equal to 1 plus R. They're the same thing, okay, raised to the x power. Only, I'm going to label each of this here. My C is my starting amount. Okay. And my 1, if I forgot, let me show you over here. I'm writing this little bubble. My 1 is the decimal that represents 100%. Okay. My 1 is the decimal that represents 100%. So that's what that is. My R is the rate. Okay. Or percent written as a decimal. Super important about that. And your X is time. Some kind of time. Minutes, days, hours, years. It's time. Okay? All right. So now when you are solving a word problem for exponential growth, You need to figure out what your starting amount is. You need to find your rate. They're going to give you a percent. Please make sure you change your percent to a decimal before you substitute it into this equation. And then please make sure that you plug in your time here to the x power. Okay, your time, and it's time. If the whole well, yeah, just I'm gonna leave it generically as time. All right, now for exponential functions, to find the percent increase of an exponential function, this is so important because we get this wrong so often because we think we can just look at it and get an answer, but we can't. We have to use this formula. This is the formula used. B is equal to 1 plus R. Okay, and it's 1 plus R because it's percent increase. That's why you got this 1 plus R. So we can't just use the number in the parentheses we can't just use the number of parentheses and go with that and choose that as the answer. That's always going to be an answer that's down there because they're going to figure that's what you're going to do. Please don't do that. So let me give you an example of how to do this. Okay, so our example, number 1. We have the equation y is equal to, and let's do 8 parentheses 1.18 to the x power. So now, in order to figure out the percent increase for this problem, this is my B here, okay? So since this is my B, I'm going to plug it in for B and solve for R, which is going to be my percent increase. It's going to be my rate or my percent increase, see? All right, so here I put 1.18 is equal to 1 plus R. To get R by itself, I'm going to subtract the 1. So when I subtract the whole number 1, I get 0.18 is equal to R. This is the decimal. This is the decimal for it. So I'll move the decimal 2 places to the right, and I get 18% increase as my answer. So this is how I find the percent increase for this problem. Okay, now the second example, number 2, let's suppose I have y is equal to 6 times, 4 to the x power. And I want to figure out the percent increase. All right. So again, I do the same thing. My B is 4. So I have B is equal to 1 plus R. And I plug in B, which is 4. I'm going to subtract 1 on both sides. And this is going to give me 3. So R is equal to 3. So the decimal, if I don't see it, is automatically behind the last number and move it over twice. So that gives me, when I move it over twice, that gives me 300% increase. Okay, so this is a 300% increase. See how you can't just look at it and tell? Please use the formula for finding the percent increase. B is equal to 1 plus R. All right, so now we got exponential decay. Okay, so exponential decay looks like this. Exponential decay, we already know exponential decay is where the curved line is going down. Okay, the curved line is going down. Now, with exponential decay, you still use the generic formula. Y is equal to A times B to the x power. But how do you know that it's exponential decay? You look at the B. If B is if B is less than 1, then that means it's exponential. This is an exponential decay equation. All right, exponential decay. So I'm trying to make sure I'm consistent. Exponential decay formula, or sometimes they might say depreciation. Oh, Lord, I spelled that wrong. Depreciation formula looks like this. Y is equal to It's the same. C is the same as A, times, and your B is 1 minus R because your rate or your percent is decreasing, okay? Because the curve is going down. So your percent or rate is decreasing to the X, or sometimes people use T power. So again, this is your starting amount. This is your starting amount, okay? This is 100. This is 1 as a decimal is equal to 100%, okay? 100%. Duh. Okay. Anyway, R is your rate, your percentage written as a decimal. Please make sure that in the word problem, if you see it written as a percent, please write it as a decimal. So, as a decimal. And then your X is the time. Your X is the time. Okay, so now you have that. Make sure. Okay, so now to find the percent decrease of an exponential function, you make sure that you use the function, use the formula. Exponential decay, okay, function. You have to use the formula B is equal to 1 minus R. It's 1 minus R because your percent is decreasing. So let's do an example. Looks like this. Number 1, you might have Y is equal to, and let's say your starting amount is 7. Okay, well, we can say 700. And remember, in order for it to be exponential decay, your B has to be less than 1. So let's do 0.625 to the X power. All right, so we're going to use this formula to figure out the percent that it decreased by. So your B is what's in the parentheses here. This is 0.625. And bring everything else down, 1 minus R. So to find out what R is, or the percent that it decreased by, you're going to get R by itself by subtracting 1 on both sides. Okay, when you subtract, you line up by the decimal. Decimal there is automatically behind the last number. All right, so what you have here is 0.625. Did I write that right? Yes. Minus 1. And this gives me a negative 0.375. Bring down the equals, and this gives me a negative R. To get R by itself, you're going to divide both sides by a -1 to get rid of this -1 in front of the R. And this gives you a positive R is equal to 0.375. So you move the decimal over 2 times, and that gives you 37.5% decrease, because this is exponential decay. Because this is exponential decay. All right. So that's how you do problems that look like that. The last thing is compound interest. Okay. Your compound interest problems Your compound interest is where your interest is being charged more than once a year. Where interest is charged more than once a year. Okay? And it's charged more than once a year. Okay? This is also an exponential growth problem. So compound interest is also exponential growth. It's an exponential growth function. Okay? So you'll know. The formula that you use for compound interest, the formula that you use is A, which is the same as Y, okay, is equal to P, parentheses 1 plus R over N to the nt power. Okay. All right. So what does this mean? This is the same as saying your final amount or your y. Final amount. And we're talking about money. So that's why they changed this letter to P, because this is principal. And principal is always talking about money. This is your starting amount. Starting amount of money. Again, this 1 is equal to 100% as a decimal. Okay. Your N is how many times interest is charged in 1 year. How many times interest is charged in 1 year. Okay? How much is it charged in 1 year? Or it's your compounded amount. Compound amount. Okay? So it's that. Interest is, make sure you count compound amount. Your T is your time, and the time has to be converted into years. Okay? Time has to be converted into years. So this is your formula. Okay? So this is what you use in word problems dealing with compound interest. Now, R, again, I need to put R here. R is equal to your percent written as a decimal. So anytime you see the percent in the problem, you need to convert your percent as a decimal before plugging it in here for R. All right, before plugging it in there for R. So now how do you figure out what N is? N, okay? N is your compounded amount. Okay, see how N is your compounded amount? So if it says, let's see, compounded amount. So if it says that it's compounded annually, that means N is equal to 1. That means interest is only being charged 1 time. If it says compounded quarterly, that means N is equal to 4. That means interest is going to be charged 4 times a year. If it says interest is compounded annually, that means interest is being charged 2 times. In this value right here and right here, which you plug in the same number, so plug in the same number twice, it's going to be 2. Biannually is the same thing. Oops, sorry. N is equal to 2. Monthly, if it's being charged monthly, N is equal to 12. That means interest is charged every single month, 12 times. Daily, oh my God, that's crazy. Interest is being charged 365 days, because there's 365 days in a year. So N is 365. Weekly, okay? So weekly, that means N is being charged 52 times, because it's 52 weeks in 1 single year. Okay? And so this is what you use to solve compound interest problems. And you'll know, because they will say compounded amount. You'll start seeing compounded amount. They're going to give you a starting amount that's talking about money. It's always dealing with money. They're going to give you a rate. They're going to say 5%, but you have to change 5% as a decimal. And if they say 24 months, you need to change 24 months to 2 years. Okay? And of course, they have to give you the compounded amount. All right, there you go. Okay, please read over your, please make sure that you go ahead and do your problems for this section. And let me know if you have questions.